Hello everyone. Today in this program of MPI, we will check that how we can write to any file and how can read this file by multi processors. Okay. So for example, in this program, I will write one message. I will prepare one message from all the processors which are involved in the communication world. For example, in my case, if there are six processors, then these six processors will generate one message, and then I will write the same message to any particular file, and this message will exactly be written there by processor 0, which will work as a master processor. And similarly, then I will read the same message by this written file. Okay, so let's start that how this experiment, this code will work. We are importing MPI from the MPI4py, and as we do in every program, we get the communication world. Communication will show that how many processors are there on your system, and the rank indicate that the particular rank of any processor. For example, if there are 100 or 10 processors are there on your computer, then these ranks start from processor 0, processor 1, processor 2, and processor 3. Rank is very important in multiprocessing because we use the rank to send any particular message towards a processor or to get any message from any particular processors. So rank is very important to distribute the task among these processes. And similarly, it indicates the size, that how many processor we are going to engage in this processing in processing this data. Okay, so hopefully this will be clear to you that the communication world indicate the total communication world, rank indicate the address, the ID of each processor, and size indicate that how many processor we are going to engage in this particular experimentation. We are creating one file name. This is variable, and in this variable we are storing output.txt. Actually, this will be our file name where we will write something there, and then we are generating one message. This message will be generated by every processor because we have one restricted here, that this will be written by processor 0, processor 1, or processor 2, because we are not going to restrict it here the processor. So every processor will come here, they will write a message, hello from processor rank of size. Rank means if processor 0 is writing this, then this will write 0 of 6 if 6 processors are there. And sorry, if processor 1 is coming there, then processor 1 will write 1 of 6. Okay, so this is a message which we are generating for number processor. Next, we are creating all messages. All messages means that we are storing all these messages. These messages mean that this message will become from processor 0, processor 1, processor 2, and this will become such like a content written in a file. So we are storing all these messages in all message variable. But how we are gathering all these messages? For that, we are using gather function, and in last video we explained that how the gather function works. Gather function actually gather the messages from each processor. Okay, uh, when we use the gather message, we don't need to properly indicate the send and receive function, because gather function do all the functionalities. It send the message toward the processors and also get the process message from the processor. So what we are getting or receiving, we are receiving the messages, and at which processor we are going to receive these messages, we are receiving these messages at root 0, which is actually a master processor. Now here we are imposing one condition, because we want to run this code on the processor 0. Processor 0 is a master processor, master node. As you know that when we work on the multiple processing, multiprocessing, um, there One processor act as a master processor, and all the other processors work as a workers or client processor. So because we have to handle the administrative task on the master processor, therefore we are imposing one condition to execute this code on a master processor. Okay, but before that there is let me come here. Okay, okay, there were some issues. Now what we are doing in this particular statement with open, okay, we are using a function open. We are sending the file because we are going to open this file. This will also write the file if it doesn't exist already. So in file name we have stored the output dot tags. This is a file name. We are going to writing access and we are opening this as a file. Okay, now what we are doing for messages, in all messages, what we have stored in all messages, in all messages we have stored all the messages which were coming from different processors. Okay, so it will run from all messages. If there are six messages, there are six content, then this code will run for all the six content. And what we are doing, file that write messages. So we are writing all these messages into the file name, which is actually output.txt. And who is writing this? The processor 0 is writing this. Now because we are going to read this file, and to read this file we are using the barrier function. Barrier function means that if processor is reading this file, no other processor can enter there to write anything. This is the reason we are synchronizing all the processors. Sorry. And for this function barrier is used. So once again we are restricting the processor 0 to read all to write or read or to run this code on the processor 0. What exactly we are doing? Open file, this is the file name. Okay, we are giving some access and as a file, and we are just printing the file content. This is a message to print the file content. And what we are doing in the print, we are reading all the file, all the content of the file. So all the content of this file will be printed. So let's execute that. How is it working? The file name of this program is file.io.py. So let me go towards the Jupyter notebook. So how I will run the running a process. The way to run the program is MPI execute. Okay, after that we indicate that how many processors can take part in that. So we are writing this for 6 processor. After that we give the Python path or the Python, and after that we write the file name or the file path. In this way the code will not run because Python exact path is not given. This will need for exact path, and file I is stored in the home directory, so no file path is needed there. So you can see that the Python file Python path is needed here. To get the Python path in a command line, you can use where path, and from where path you can copy this path to give a full path there. Okay, so I'm giving a full path which is actually that one. In my case there are some spaces, and when there are some spaces you must include that in a quotation mark, so this may not give any error. So let's execute this one now. So you can see that every processor is writing there, and after that we are reading from this particular file. Let's go towards the home directory. We will see that the same file will be created here somewhere in the this one. the output text is created. Let's open that, and we can see that the some message is written here. Okay, if we want to write anything else here, then we can also write okay. Let's execute this code for this particular message. Yes, you can see that hello farm processor 0. This was the first message which was written there, and this is the new message which is written there. So hopefully this will be clear, and you probably you have got the idea that how the multiprocessor MPI work, and how it write messages to a particular file, and how we can read this particular file using the MPI 4py. Thank you so much.